Hey guys, today we're going to talk about what a series is. So, to me, when I hear series, I think of like a series in baseball where two teams play each other for however many games, or maybe like a TV series or something like that. And so the sequence idea with the series made sense since it was something kind of sequential, right? So what a series actually is the sum of all the terms in a sequence. So, a series in baseball, you have to take the sum of all the wins and the losses to find out who won the series, right? A TV series, it's not just one episode; it's the combination of all of that together that makes the series. So, a series is the sum of all the terms in a sequence. So, sometimes how you'll see it is you'll see it in sigma notation. That's what that E looking thing is. It's actually an S for sigma. I is the index of summation. It can be any letter you want it to be, I, K, X, whatever. And we usually start at 1. So that bottom number is your lower bound. That's the term number that we start with. That number up on top, my n, is called my upper bound. That's the term number that I end with. So if I want to find the sum of the first n terms, I'm going to go from 1 to n. If I want to find the sum of the first 5 terms, I'd go from 1 to 5. Make sense? Cool. All right, so we want to find the summation from 1 to 5 of 3i. So here's what that means. We're first going to plug in 1. So 3 times 1 is 3 plus. Then we'll plug in 2. So we'll add 6. Then we'll plug in 3. So we'll add 9. Then we'll plug in 4. So we'll add 12. Then we'll multiply by 5. That's where we're ending. So we'll add 15 at the end. So then we'll take 3 plus 6 plus 9 plus 12 plus 15. And we'd end up with 45. Now, if you wanted to do this on your calculator, here's how you're going to do it. So the first thing you're going to do is press on math. I'm sorry I don't actually have my calculator emulator up on here. For some reason it keeps saying I don't have a license. I don't know why. I'm trying to get it fixed. Anyways, so we're going to click on math. And then if you go up, you're going to see 0. It says summation, and then it has a little sigma on it. That's the one that we want. We'll press enter. And then it'll give us each of those blanks. It'll have a little alpha guy where it wants us to put in a letter for that guy. I tend to just go ahead and use X for a variable. Our lower bound is 1, so we'll have our 1 down there at the bottom. Push up into the top and put a 5. And then we'll put 3x after my sigma. And we end up with 45, so we get the same answer. Okay, go ahead and try that next one. All right, so whether you did that by hand or if you put it into your calculator, we should have ended up with 86 for that guy. Okay, let's look at some properties of sums. So if we have a sequence where all it is a constant, so the sequence is maybe like 4, 4, 4, 4, 4, and every single term is 4. So if we have something like that, if I were to take the sum of the first however many terms, I'm just going to take that constant that we had for our sequence and multiply it by how many terms we had. So what I mean by this, how this will look if you ever do come across it, is if we have I equals 1 to let's maybe do 3, and maybe our let's say that our sequence is 4. So that means we have 4, 4, 4 forever and ever and ever and ever, right? Well, if I want to add up the first 3 terms, I'm going to take 4 plus 4 plus 4 and get 12. And notice that's the same thing as 3 times 4. Cool. Over on this next one, if I have the summation from 1 to n of a sub I plus or minus b sub I, basically what we can do is if we have a sum or difference of two different sequences, we can go ahead and find those sums separately and then add or subtract them. So that way we don't have to find out what is the stuff for, combining those two sequences together. Okay. Then there's something called a partial sum. So the biggest confusion about this is not how do you do it, it's knowing what a partial sum is. So partial sum means I stop adding eventually. Or it's kind of like you terminate. You stop, you have a last term that you add on. So a partial sum, sometimes you'll hear something called the fifth partial sum. Oopsies. So the fifth partial sum means that I want to take my first term all the way up to my fifth term. We want to find the sum of that. So whatever if partial sum you want, that's going to be your upper bound. An infinite series means that we're just going to keep on adding up these values forever and ever and ever and ever and ever. So we're going to take a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 all the way out forever. And here in a second we'll see how we can actually get a value for that. So in this guy, we want to find our third partial sum and just the sum that it asks for. So we want the third partial sum. The third partial sum means that I want my sigma from I equals 1 to, since it's my third partial sum, I want a 3 up there on top of 3 over 10 to the I. So if we plug in 1, I get 3/10. And just for help, I'm going to put 0.3 right there since it's the same thing. If we plug in 2, we're going to end up with 3/100, or 0.03. If we plug in 3, we end up with 3/1000, which is 0.003. So then when we add those together, we end up with 0.333. And that's my third partial sum. Now I could have also gone into my calculator and done it. I'm going to walk you through it one more time. Math, go to 0. I'm going to put it as x equals 1. On top of my sigma goes the 3. And I'm going to go ahead and put in my fraction of 3 over 10 to the x power, and I'll press enter. And I end up with 333 thousandths, which is exactly what we got here. Now we want the sum. So the sum means I actually want from 1 till infinity on this guy. 3 over t to the I. So here's what we noticed just a moment ago. On that first term, we got 0.3. With my second term, we got 0.03. With my third term, I got 0.003. With your fourth term, you're going to end up with 0.0003, and so on and so forth, right? So with every term, I'm adding another 3 onto the end of this, right? Not necessarily adding, but you know what I'm saying. I'm having another 300,000th, 100,000th, so on and so forth out there, all the way out, right? So if I have 0.333333 forever and ever and ever, then we know that's 1/3. So sometimes our infinite sum will actually arrive at a number, and this is our case at 1/3. All right, see you guys later.